what we want to look at now is we want to go to section 5.6. We want to continue our topic on factoring. We have looked at two different techniques of factoring up to this point. Excuse me. The first type of factoring we looked at is, doesn't matter how many terms it has in it, whether it has 2, 3, 4, 5, 6 terms, whatever. The first thing we do is we always look at every term and we see if there is a greatest common factor other than one that will divide into every one of those. So we call that checking for the GCF. And remember, when you check for a GCF, your GCF can be a number or a letter or numbers and letters, and those letters can even have powers on them. But we talked about that in the first part of section 5.5. Then we went to another type of factoring called factoring by grouping. Now, you still look for a GCF first, but grouping is a particular method of factoring that works particularly well with a problem that has 4 terms in it. That's one of the visual distinctions of when you're probably going to try grouping, is if your polynomial being factored contains 4 terms. Okay, so what we're going to do now in this next section is we're going to look at factoring trinomials. Now, of course, you know what a trinomial is, a trinomial that has 3 terms. But what we're going to concentrate on in this section is not just any old trinomial. The trinomials that we're going to talk about is going to be of a specific form. What that means is it means it's not just going to be 3 terms. It will have 3 terms, but it's going to have a certain look about it. And so let me show you what we're talking about when we talk about trinomials. Let me show you what the form looks like. Here are the 2 forms that I'm talking about. Now, I know this doesn't mean anything to you right now, but it will as we go through this. So let me explain this first. First of all, B can be positive or negative. B is any number. C is any number. Over here, A is any number, positive or negative. B is any number, positive or negative. C is any number, positive or negative. So here's what we mean. Now, don't get hung up on this letter X. It doesn't have to be an X. Though it will most of the time, it doesn't have to be the letter X. But this is what I'm wanting you to hear me say. We're going to call this case 1 trinomials. And what I mean by case 1 is you're going to have a letter squared, and then this can be either a plus or a minus, some number times that same letter, plus some other number. So let me give you just some examples of this first type. Like x squared plus 3x plus 2. Or x squared minus 7x plus 10. That's what I'm talking about. A letter squared plus or minus some number times that same letter. So whatever letter is being squared is also in the middle. And then plus or minus some constant. One more, just to show you that it doesn't have to be x squared. It could be m squared minus 2m minus 15. So let me emphasize this one more time. We're talking about factoring trinomials that have a certain look about them. They'll all have 3 terms. The first term will be a letter squared. The middle term will be some number times that same letter to the first power, plus or minus some other number. So everything I'm going to be talking to you about in the probably next couple of videos is going to all revolve around ones that look just like this. So if it doesn't look just like this, you can't use what we're talking about. So we're talking about only of a specific form. Well, you say, well, Mr. Rainer, what if they don't look like these? Then the only thing you can do is check for a GCF. That's it. Because grouping works on a problem that has 4 terms. So this is what I call case 1 trinomials. You'll hear me sometimes call this the easy case. Now, what is the difference between the easy case specific form and the harder case? If you'll notice, I put a number, I put an A right here. What I mean is this: anytime there is a number in front of x squared other than 1, see, all of these have 1 in front of it. If there's any other number in front of that x squared, that's what I typically refer to as the harder case. So let me just give you some examples of what it would look like. So 2x squared plus 3x plus 7. 5y squared minus 8y minus 9. 2m squared minus 7m plus 1. And the reason we're breaking this up into 2 different cases is because the process by which we factor these is completely different than by the process that we factor these. Okay, so what we're going to concentrate on in just a few minutes is we're going to concentrate on the easy case trinomials. So ones that look like this right here. All right, before I do that, let me show you, or let me remind you of where one of these trinomials comes from. So let me just show you a couple of examples right here. You don't have to write this down, just kind of sit back and watch. If I multiply x plus 4 times x plus 5, if I FOIL this out, we talked about this several sections back. There's the FOIL method. Now if I add the 5x and 4x together, now look at this right here. This is what we're going to be starting with in a minute. So right now what we're doing is in just a few minutes, I'm going to give you this problem, and we're going to have to go backwards and find this answer right here. Let me do one more. This is using the FOIL method. I'm not talking a whole lot there because we talked about that in great length. So in just a few minutes, I'm going to give you this problem, and we're going to go backwards and try to get this right here. All right, so here's what I want you to do. Let's just pretend for just a second that we wasn't looking at the answer. Okay, so I'm going to show you something. Really, really important what I'm about to show you, so make sure you watch this. First of all, when we factor a trinomial of this type, of course I always look for a GCF first. But none of these of this type will have a GCF, though I will still mention it. So there's no GCF. Whenever you factor a trinomial that doesn't have a GCF, it will always factor as a binomial times another binomial, unless it's prime. So if this does factor, it'll be a binomial times another binomial. Now watch this. Where did the x squared come from? The x squared came from x times x. So that's going to make this part, when you factor x squared, what times what gives you x squared? Well, x times x. That's why we call this the easy case. Now, here's where the dilemma comes in, is the 20. Because the numbers that go last have to multiply together. Remember FOIL? The numbers that come last have to multiply together to give you 20. Well, that's where the problem is. Because if you multiply 1 times 20, you get 20. You get 2 times 10, you get 20. And you get 4 times 5, you get 20. So there's more than one option, unlike the x squared, which is x and x. Now, let me show you how you decide which numbers work. When we did the 5x and 4x and got 9x, what did we do to the 5x and 4x to get 9x? We added them. We added 5 and 4. Now, what do you get if you multiply 5 and 4? You get 20. But if you add 5 and 4, you get what? 9. So here's how you figure out what numbers to pick. Watch this, very important right here. You ask, to fill in the last 2 spots, you ask yourself this: what 2 numbers multiplies together to give you 20, but if you add them together, you get 9. Multiply to give you 20, adds together to give you 9. That would be 4 and 5. And to multiply to give you a positive 20 and give you a plus 9, they both have to be plus. Now watch something right quick. And again, just watch. We're going to do a whole bunch of these in just a few minutes. What would happen, I'm going to do this in red. What would happen if this had been minus and this had been minus? So let's see, then this would be minus and this would be minus. Now, would this still be 9x? Yes, it would. But now this would be a minus. So how would that change things? Now both of these signs would have to be negative, because a -4 and a -5 is a -9. So this is what I want you to see. When you're factoring a trinomial, if this last sign is plus, that means the signs in your 2 answers have to be the same. They can both be positive, because what's a +4 times a +5? A +20. But they can also both be negative, because a -4 times a -5 is a +20. So what this tells me, anytime that last sign is a plus, that means the signs are the same. The first sign tells you what they are. So this means the signs are the same, both plus. This means the signs are the same, both negative. Now, how do you decide what numbers to choose? Whatever adds together to give you 9. So this says the signs are the same, both plus, signs are the same, both negative. So actually, I will fill in my signs before I even put my numbers in. And you'll see in just a minute when I get to these examples what I'm referring to here. All right, so let's look over here at this next one, and then we'll do some examples. Okay, we said that if a trinomial doesn't have a GCF, when you factor it, it will factor as a binomial times itself. All right, x squared. How can you break up x squared? Well, it's x and x. It's the first, x and x. So that's why we call this the easy case. Now, we need 2 numbers that multiply to give you 10. But notice this. The 2 numbers that multiply to give you 10 now has to be a -10. So if I said give me 2 numbers that multiply together to give you a negative, doesn't that mean that one of them has to be positive, one of them has to be negative? So if you're going to multiply to get -10, one of them's got to be positive, one of them's got to be negative. Now, it doesn't matter whether the positive is in the first parentheses or the second parentheses, but it will matter what you put behind them. Here is why. Now what you do is you say, I need 2 numbers that multiply to give you 10, that subtract to give you -3. What 2 numbers, if you multiply them, you get -10, but if you subtract them, you get a -3. 5 and 2. But the 5 has to be negative in order to get a -3. So if you take a negative 5 and a positive 2, if you multiply them, you get negative 10. But if you add those two together, or it's actually subtract, you get negative 3. So that's the answer. So let me say this one more time, and then we will look at some examples. Whenever we break up the x squared, that's always going to be x and x. Always. That will never change. How do we determine what the signs are going to be? If this last sign in your trinomial is a plus, that means the signs are the same. If the signs are the same, you look at the first sign to see what they're going to be. Signs are the same both plus, signs are the same both negative in your final answer. Now, this over here says the signs are different. So that means one's a plus, one's a minus. It will not matter what you put where, but it will matter what you put behind the plus and minus. So now I have a plus and minus. So to fill in the last two spots, then you say this. I need two numbers that multiply to give me 20, that adds to give me 9. Two numbers that multiply to give me 10, that subtracts to give you 3. So what determines whether you're adding or subtracting to get that middle number is whether that last sign is positive or negative. Now, I know that's still confusing. When we work with, in this next video, we're going to work a whole bunch of examples of nothing but this easy case. And I will say it 1,000 times over. So the more times I say it, the more it will begin to stick. So that's what we're talking about when we talk about factoring trinomials, the easy case. Now, when I change this number to say a 6x squared, that's a game changer. That's the harder case. And the reason is, if I put 6x squared here, that could be 2x and 3x, or maybe 3x and 2x, or 6x and 1x, or 1x and 6x. So when you put a number in front of that x squared, that's a complete game changer on how you factor that problem. But we're not near about ready to discuss that yet. Next couple of videos, we're going to be doing nothing but working on factoring trinomials, the easy case right now. So I'm going to go ahead and stop this video here, and then we'll pick up. This is section 5.6 video part 1. So we'll continue with part 2 in the next video.